Hello everyone, in this video I will go over my solution for the problem named no prime differences taken from today's Codeforces round. This is an excellent problem which will teach you constructive algorithms on grids. Specifically in this problem we need to fill the n by m grid with a permutation from numbers from 1 to n times m such that no two adjacent cells have a prime difference. So we need to find and print such a solution for any values of n and m, where an important constraint is that n and m are greater than or equal to 4. The construction which I provide will not work for n and m less than 4, so you need to be careful. In the first example, you can see that one possible construction is in which you print this grid and you can verify that the differences between adjacent elements are not prime. An important observation is that 1 is not a prime number and even numbers are not prime numbers. That's the key idea which we'll be using in our solution. Because if you know that 1 is not a prime number, you can just place consecutive elements in the same row in the grid. And if you know that even numbers are not prime numbers, you can figure out a way to arrange consecutive numbers in blocks such that the differences between the columns, the differences between two adjacent rows in the same column will have an even difference. So I'll be explaining exactly how we do that. So notice that 1 and 2m are prime. We'll be using these two non-prime numbers, sorry. 1 and 2m are not prime. So the key observation is that since 1 and 2m are not prime, you can make sure that the adjacent elements have difference 1 and 2m. And you can do this with the following construction. So the first idea which will come to your mind is just putting consecutive elements in rows and placing them one after the other. So 1, 2, 3m, then m plus 1, m plus 2, m plus 3, 2m, and then 2m plus 1, 2m plus 2, 2m plus 3 all the way up till 3m. And this construction fails if m is prime because the consecutive rows in the same column will have a difference of m, which can be prime. However, if you make sure that the difference is 2m, then that won't be prime, and that's why that construction will work. So this is the outline of the construction which I was suggesting. We put 1 to m in the first row, and then 2m plus 1, 2m plus 2, 2m plus 3 all the way up till 3m in the second row, and then 4m plus 1 and so on till 5m in the third row. And in general, we place all the even number times m plus even number times m plus j. So I times m plus j where I is even. You can do that, and then separately do I times m plus j where I is odd. The only issue with this solution of separating the odd numbers and the even numbers and then placing them one after the other is that overall it looks to be fine because adjacent elements have a difference 2m, they have a difference 2m, and elements next to each other in the same row have a difference 1. So in general, if you consider two random elements, they should have a difference of 2m, which is not a prime, and that's why this solution should work, because you're just taking the differences to be non-prime. However, if you consider the border, if you consider this separation over here, then you will realize that this difference between the two separations can actually be prime in the case when n is 4. So I try to code the solution and it actually fails for n is 4 because this difference turns out to be a prime number, which is why a simple solution is to reverse the two orders. So instead of printing 1, 2m and then 2m plus 2, 2m plus 2, 3m, so on, first you print them after you print all the odd elements. So first you print the odd numbers m plus 1, m plus 2, 2m, then 3m plus 1, 3m plus 2, 4m, so on until less than n, and then you do the same thing over here from 1 to m, 2m plus 2, 2m plus 2, 3m, all the way up to less than n. And you can verify that this solution gives the correct answer even when n is 4. And this solution satisfies the property that any two elements have a difference 2n or 1, which is a non-prime number. So I'll show you the code which implements the same idea. So in the code for each test case, I taken the value of n and m. I print the odd values of I first, and then the even values of I. And each time I'm just printing I plus m plus j, I times m plus j. And you can verify that this code does get accepted for all cases. So I hope you like this problem and my solution. If you have any doubts in any part of the code or in the construction, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.